Okay. So I said this is the corrected version of the correction to the third assignment given. Okay, so moving on to today's class, does anyone have any questions relating to indices? Hello, can you hear me?
Yes, ma. No question, ma.
No question. So you perfectly understand everything that has been explained.
Yes, ma.
So those that were present at last week class, how do I get your assignment? Because I'm actually supposed to check what you did.
I've submitted my own on the group chat.
Okay. Okay, don't worry. I know how to go about that. So today we'll be talking about standard form. Standard form is a common topic in mathematics. It must have been treated in even junior secondary school classes. So this should be like a revision class for us. Am I right?
Yes, ma.
So when we talk about standard form, can anyone tell me what he or she understand by standard form? Yes, standard form. What does it mean? What comes to mind? I'm asking a question and I'm expecting an answer. Hello? Hello? Can you hear me?
I can hear you, ma.
Okay, so there's no answer to the question I asked.
No answer, ma.
Okay. So that means you don't know anything about standard form, or you don't want to talk. Which of the following? Why are you
I don't know
always
how
the
to put it down.
speaking?
I don't know how
I
to
think
put it down, but from what I understand, is the easiest way of writing numbers.
Did you copy what is on my screen or what you know?
No, is what I know, because if you want to write something like 1 million, it's the same as writing 10 raised to the power of 6.
Okay, thank you. Any other person? It's like she's the only one always speaking in my class. So is there no male there? Okay, I think you're the only one. Okay, so today I'll be speaking on standard form. So standard form, as you can see on the screen, is a way of writing very large or very small numbers down easily. Just like you said, an easy way of writing out numbers. So instead of writing out numbers in big form, you want to write a long digit of numbers. Standard form helps us like abbreviate. Just like we use the word abbreviation in English, we use standard form in mathematics. It is the simplest way of presenting a mathematical expression. You want to write an expression in a simple form. That's where standard form comes into play. Standard forms are always written in the power or exponent of 10. That's one thing we should note. When we talk of standard form, we are talking of the powers of 10. The base used is always 10. So maybe you have, for instance, we have 1,000. 1,000 is the same thing as 1 times 10 raised to the power 3. And like you said, once you write 1 million, we write it as 10 raised to 6. Want to write trillion, we write it as 10 raised to the power of 12. and so on and so forth. The second example, if we want to write 5 times 10 raised to the power of 3, x to the power of 3 is 1,000. So that gives us 5 times 1,000, which is 5,000. Then we have 0.0008. So standard form is not only used in whole numbers. Standard form can also come into play where we have decimal numbers. So looking at this third example, we have 0.0008. If we want to write this out in standard form, it is written as 8 times 10 raised to the power of minus 4, as 0.0001 is equal to 10 raised to the power of minus 4. How do we know that 0.0001 is equal to 10 raised to the power of minus 4? Let's check that out in the next slide. Now we also write this number 7,210,000,000,000 in standard form. 7,210,000,000,000. Writing it out in standard form, we said it is written as 7.21 times 10 raised to the power of 12. Now, how do we know these powers? Just like I said that, how do we know 0.0001 is equal to 10 raised to the power of minus 4? The power tells us how many times the decimal point has been moved. For instance, looking at 1,000, we write it as 1 times 10 raised to the power of 3. That means a decimal point came into 1,000 after 1, because we wrote 1 times. After 1, all other numbers were cut off. So what happened to other numbers? That means decimal point was introduced. Now, if you put a decimal point after 1 and you move the decimal point to the last 0 in 1,000, you move it by putting the decimal point after 1. We have 1, 1, 2, 3. Moving from after 1 to after the first 0 to the second 0, then to the third 0, that gives us what? That means we moved 3 times. So the power tells us how many times the decimal point has been moved. Now, looking at 0.0008, we wrote it as 8 times 10 raised to the power of minus 4. That means this decimal point, there's a decimal point in this equation before. So that means the decimal point moved from where it was, from here, to after 8, because it is written as 8 times 10 raised to the power of minus 4. Now, how many times did the decimal point move? If we count it, we have 1, 2, 3, then 4. So that's what gives us 8 times 10 raised to the power of minus 4. So our power tells us how many times decimal points moved. Looking at this 7,210,000,000,000 also, we imputed decimal points after 7. And we know that zeros after decimal point are not significant. So that's why we wrote it as 7.21 times 10 raised to the power of 12. Introducing decimal point after 7, and then you move it to the last digit, which is here. If you count how many times it moved, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's what gives us our power. Do you understand? Hello?
Yes.
Hello?
Yes, please continue.
Okay. Now on to addition and subtraction in standard form. Under standard form, we have different operations. Basic operations can be done: addition and subtraction, multiplication, and division. So now looking at the addition and subtraction in standard form. The first example we are giving is 4 times 10 raised to the power of 2 into brackets plus 5 times 10 raised to the power of 2 into brackets. Now, when you are dealing with power or exponent, it is easy to add up, subtract, multiply, or divide when you are working with the same power. Looking at this first example, we have 4 times 10 raised to the power of 2 plus 5 times 10 raised to the power of 2. That means the power in the first bracket and the power in the second bracket are the same. So we can just bring out what is common to both brackets. Bringing out what is common to both brackets, we have 10 raised to the power of 2 common to both brackets. So when we bring out 10 raised to the power of 2, which is common to the brackets, we have 4 plus 5 left, 4 in this bracket, and then 5 in this bracket. So we have 4 plus 5 times 10 raised to the power times 9. So that gives us 9 times 10 raised to the power 2, which is 9 times 100. 10 raised to the power 2, 10 in 2 places, 10 times 10 gives us 100. So that's 9 times 100. Our answer is 900. And the second example, it says 8 times 10 raised to the power of 5 plus 4.5 times 10 raised to the power of 3. 8 times 10 raised to the power of 5 plus 4.5 times 10 raised to the power of 3. Looking at this second example, we see that the powers are different. In the first term, we have 10 raised to the power of 5, while in the second term, we have 10 raised to the power of 3. So what do we do about this? Just like we did in the first example, we bring out what is common to both terms. What is common to 8 times 10 raised to the power of 5 and what is common to 4.5 times 10 raised to the power of 3. 10 raised to the power of 3 is common to both terms. 10 raised to the power of 3 is common to both terms. When we bring out 10 raised to the power of 3, in the first term, which is 8 times 10 raised to the power of 5, what do we have left? We have 10 raised to the power of 3 into 8 times 10 raised to the power of 2. Because when you open your brackets and you multiply that, you have 8 times 10 raised to the power of 5. So when we bring out 10 raised to the power of 3 from 8 times 10 raised to the power of 5, we have 8 times 10 raised to the power of 2 left. And then when we bring out 10 raised to the power of 3 in the second term, we have 4.5 left. Adding up, we have 10 raised to the power of 3 into, this is a bigger bracket, then 8 times 10 raised to the power of 2 from the first term, plus, don't forget your addition sign. There is a link between the two terms, which is addition, plus 4.5 from the second term. 8 times 10 raised to the power of 2 gives us 8 times 100 plus 4.5. So we have 10 to the power of 3, 10 raised to the power 3, bigger brackets, into bracket of 8 times 100, 8 times 10 raised to the power 2, which is 8 times 100, plus 4.5. So we have 10 raised to the power of 3 into 8 times 100 gives us 800, 800 plus 4.5, which is 10 raised to the power 3 into 804.5. When we add up 800 plus 4.5, we have 804.5. So we have 10 raised to the power of 3 into 804.5. 10 raised to the power of 3 is 1,000. So this gives us 1,000 times 804.5, which is 804,500. Or you leave your answer in standard form, depending on how you are asked to leave your answer. Leaving your answer in standard form, we have 8 points. I didn't write it there. We have 8.045 times 10 raised to the power of 5, because we'll be putting decimal points after 8, and then to the last digit. That means it's moved down many times. 1, 2, 3, 4, 5. So in standard form, we have this as 8.045 times 10 raised to the power of 5. The third example we'll be looking at, do you understand what I've explained in questions 1 and 2? Hello? Hello?
Hi.
Do you understand what was explained in examples 1 and 2? Or you are not following? Hello? Okay, we move on to question 3, example 3. Here, we have 6 times 10 raised to the power of minus 5 in bracket minus 5 times 10 raised to the power of minus 7 in bracket. Here also, we collect what is similar or common to both terms. 6 times 10 raised to the power minus 5, 5 times 10 raised to the power minus 7. What is common to both terms? 10 raised to the power of minus 5 is common to both terms. So when we bring out 10 raised to the power of minus 5 from the first term, which is 6 times 10 raised to the power of minus 5, we have 6 minus, when we bring out 10 raised to the power of minus 5 from 5 times 10 raised to the power minus 7, we have 5 times 10 raised to the power minus 2 left. So we have 10 raised to the power of minus 5 into a bigger bracket of 6 minus 5 times 10 raised to the power minus 2 in a smaller bracket. So we have 10 raised to the power of minus 5 into bigger bracket 6 minus 10 raised to the power of minus 2 is the same thing as 0.01, writing it in ordinary form. So we have open bracket 5 times 0.01 close bracket, close bigger bracket, equals to 10 raised to the power of minus 5 into bracket of 6 minus 1 multiply 5 times 0.01. We have 0.05. So what is inside the bracket gives us 6 minus 0.05. And then outside the bracket, we still have our common term, which is 10 raised to the power of minus 5. So this gives us 10 raised to the power of minus 5. When we subtract 0.05 from 6, we have 5.95. So we have 10 raised to the power of 5 times 5.95 as our answer. If we want to write this out in ordinary form, we should have 0.00595. Moving to the fourth example, we have 8.73 times 10 raised to the power of 8 minus 2.18 times 10 raised to the power of 5. Now, there are different ways we can solve addition and subtraction in standard form. So I decided to use this example to show us the second way or the other way of solving. If we don't want to go about bringing out what is common to both sides, we can solve it this way. So we have 8.73 times 10 raised to the power of 8. 10 raised to the power 8 is the same thing as 100 million. So we have this first term, which is 8.73 times 10 raised to the power of 8, as 8.73 times 100 million. And then we have the second term, which is 2.18 times 10 raised to the power of 5. When we multiply this, 10 raised to the power of 5 is the same thing as 100,000. So we have 2.18 times 100,000, which gives us 8.73 times 100 million minus 2.18 times 100,000. So this gives us 873 million minus 218,000. 873 million minus 218,000. When we subtract this, we have 872,782,000. That's 872,000. expressing this in standard form, we know that our decimal point always comes after the first digit, the first number. So we have putting our decimal point after 8. That means we have to the power of what? Let's check how many times we move. We move 1, 2, 3, 4, 5, 6, 7, 8. So we have 8.7278 times 10 raised to the power of 8. This is our answer. This is the second way of solving questions or of solving addition or subtraction in standard form, related to standard form. Any question from the explanations I've done?
No, go ahead.
Hello, do we have any question?
No, you can go ahead.
Okay. That means we understand all that have been explained. That will be all for today. So I have an assignment for us, which is this. Can you see the screen?
Yes.
That will be our assignment for this week. So you'll be submitting on the group before Sunday class. Abi, I think there's a group chat.
Yes.
Am I right?
Yes.
So this assignment is to be submitted on the group prior to Sunday.
Okay.
So this will be all for today. No question. All right.